Now closed system, open system and isolated system, we have seen the definition. Now there are two more cases. One is homogeneous system, which is having a single phase only, whereas another one is a heterogeneous system, which is having two or more phases. So for example, if there is a water, then it is a single phase system. But if that water, boiling water, suppose it is converted to steam, wet steam, then wet steam is having some water particles in suspension. So it is the case of the heterogeneous system. A pure substance is defined as what? A homogeneous, and it is having homogeneous and stable chemical composition, even though there is a change of phase in the working substance. So that is known as the pure substance. Now let us see with the help of simple example whatever the systems which we have studied. So first one is the closed system. So here you are having the heat which is supplied to the gas because of the application of the heat energy. So Q is the heat energy which is supplied. The gases, they will expand and they will exert the force at the bottom side of this piston, and the piston will start moving in the upward direction. So you have obtained the motion of the piston and piston rod. So mechanical work is obtained, but gas is not leaving the system. So that is the definition of the closed system. In closed system, there is no transfer of mass, only energy transfer is taking place. Now in case of the turbine, suppose high pressure gas is allowed to expand. Now here the turbine blades, they are not shown. Then the turbine shaft starts rotating. So work is obtained at the turbine shaft. The high pressure gas, after performing the work, will leave as a low pressure gas. So this gas is which is having the gases which is high pressure, high temperature gases, they are having heat energy and that is getting converted to work energy. Some part of the heat is rejected to the surrounding. So here there is a transfer of mass, that is high pressure gas is entering from one side, low pressure gas is leaving on the other side. So there is a mass transfer, that is high pressure gases entering and low pressure gases leaving, and there is energy transfer also. These high pressure, high temperature gases, obviously they are having heat energy, and when they expand on the turbine blades, some work will be obtained. So there is a energy transfer also. This system where we are having the energy transfer that is taking place, that is known as the control volume, and this is imaginary surface which is provided as indicated by this dotted line, and that is known as the control surface for the analysis purpose. Now in case of the isolated system, we have seen that suppose you are having a high pressure, high temperature gas which is kept inside the this particular, it is confined in a volume, and insulation is provided on this rectangular box, suppose, or rectangular duct is provided, suppose, over here. Then because of this insulation, there is no transfer of heat from system to the surrounding or from surrounding to the system, then that is known as the isolated system. Now the most important part is the thermodynamic property. So a thermodynamic property is the characteristics which can be used to describe the state of a system. For example, you can use temperature, mass, energy, pressure, volume, etc. So energy is having the unit of joule or Newton meter, or kilojoule or kilonewton meter. Mass is in kg, temperature degree centigrade or Kelvin, pressure is in bar kilopascal or meter of water, mm of Hg, etc. This B should be small. Volume is in meter cube or liter. So for example, suppose you are having a gas cylinder in your house, then how you can describe that particular gas cylinder is what is the pressure of the gas which is there inside that particular gas cylinder, and what is the volume of that particular gas cylinder, and what is the mass of that gas which is present inside the cylinder. So you can say that we have described that gas cylinder in terms of mass, volume, pressure of the gas, like that. So that is known as the thermodynamic property. Suppose boiling water is there and you put a finger inside it, then the temperature will be sensed by your finger. So that is the temperature which is sensing that particular boiling water. What is the temperature? Temperature is very high. So temperature is identifying or character is the characters which is used to describe that particular vessel in which that boiling water is placed. Then what is the volume of that vessel, what is the mass of water which is present inside the system, like that. So these are all thermodynamic properties. Now there are two types of the properties, which are not dependent or independent of mass of the system. Those are known as intensive properties. And another one which are dependent on the mass of the system. Those are known as the extensive properties. So independent of the mass of the system are pressure, temperature, density, viscosity, thermal conductivity, electric potential. We will not consider these values. We'll consider pressure, temperature, density, viscosity, mass, energy, enthalpy, volume, entropy. These are the extensive properties. So electrical values we will not consider over here. Now the most important part is what is the point function and what is the path function. Now as you can see, suppose we are having a pressure volume diagram. So here it is P, that is written. P is pressure is taken on y-axis and volume is taken on x-axis. Now the thermodynamic process is carried out from 1 to 2. These are the endpoints. We will see what is the meaning of process, cycle, etc. Suppose these are the endpoints 1 and 2. Draw a horizontal line, then it will intersect y-axis at P1. Draw a horizontal line from 2, it will intersect y-axis at P2. Then draw a vertical line so that it will intersect x-axis at V1, and draw a vertical line from 2 so that it will intersect x-axis at V2. So P1, P2, V1, V2, these are dependent on the state of that particular system, or these are the point function, because at point 1 thermodynamic property is are P1 and V1. At point 2 thermodynamic properties are P2 and V2. Suppose you consider any intermediate point on this line, on this curve, then draw a vertical line from this. Suppose it is V3 and this is P3. So we can say that each and every point on this point will represent different values of pressure and volume. So point is important, and this point is nothing but what? State. So these are known as the state points. One is state, second is state of the working substance, and such points, when they are joined together, we are getting this process. But in case of the path function, instead of these end values, the that is 1 and 2, the path which is followed during that particular process is important. Draw a vertical line from 2, draw a vertical line from this, then area under this pressure volume diagram, that is this particular area, which is complicated in some cases. We are considering only 1 to 2, this upper path, correct? And this, you can consider this lower path also, and then consider this as your area of the integration. You can integrate this and find out the area under this curve. Then as the value of the particular property, for example, area under this PV diagram, you have to consider at a time only one path, that is path A or path B, correct? Then suppose we consider path A like this, then, and if you draw the ordinates or vertical line from this area, if you calculate by integration, then that will always represent the work done. So area under PV diagram always represents the work done according to the definition of work. So here you can see point function, two thermodynamic properties, locate a point on the coordinate axis. So here you are having pressure and volume as the coordinate axis. Then state point 1 is characterized by P1 V1. State point 2 is characterized by P2 V2. Any other point, intermediate point, will be characterized by P3 V3, P4 V4, etc. So point is important, and at each and every distinct or different points the values are different, that is pressure and volume, they are different. So that is known as the point function. For example, if you integrate this, then you can say that integration of dv is v, and the limits are from 1 to 2. So it is v2 minus v1, upper limit minus lower limit. Therefore we can write down the integration like this, when it is a point function. And these are the cases, these are the examples of the point function, that is pressure, volume, temperature, internal energy, entropy, enthalpy, etc. Whereas what is the path function, that is important? Thermodynamic properties which cannot be located by a point. So here, as you can locate this by a point 1 2 3 4 etc., you cannot locate it by a point on the coordinate axis. So PV is the coordinate axis. Then but they are located by the area under the curve. So area under this dw, suppose, so these are the inexact differential, these are the exact differential. So it cannot be written. For example, dw, generally we say that it is, the integration is w, and if the points are from 1 to 2, mathematically it is w2 minus w1, but that is not the case. It cannot be written as w2 minus w1. It simply we can write down is as work done during the process 1 to 2. Similarly, heat also cannot be written as Q2 minus Q1. It has to read like this: heat supplied during the process 1 to 2, or heat rejected during the process 1 to 2, like that. So heat and work are the path function. They depend on the path followed by the system, not the end points or in between points within the system. So point function, they are exact differential. You can easily find out the integration of that by substituting the upper limit minus lower limit. But in case of inexact differential, it cannot be written simply as W2 minus W1. It is work done during the process 1 to 2. Either work done by the system or work is done on the system. Here also Q12 is nothing but heat supplied by the system or heat supplied to the system or heat rejected by the system. So that is the difference between the point function and path function. Now there are different forms of work. Electric work is there, that is EI into dt, where I is the current, C is the charge in coulombs, and E is the voltage potential. So definition of current according to electrical engineering, we see it is the rate of change of coulomb. Then shaft work is torque into theta. Shaft power is T into omega, or 2 pi nt by 60. 2 pi nt by 60. Then wheel work or stirring work, when we stir something, then what will happen? So that work is represented by this. Then flow work is the work which is required to move the fluid from one place to another place, that is given by PV. And displacement work, which is important from the thermodynamics point of view, so it is pressure into change in volume when it moves from state 1 to state 2. So these are the various types of the works which are there.